Okay, section 5.2. We will be moving forward with our quadratics, and we're going to do Introduction to Solving Quadratic Equations. Now, a lot of your quadratic equations before in geometry you used Pythagorean theorem. We're going to continue to use that, but we're going to look at how our variables and or numbers stack up in our Pythagorean theorem. We might have to do something with them. And definitely dealing with roots. So let's start with solving quadratic equations of the form x squared equals a. If you can get your equation to match x squared equals a, then they're saying a has to be greater than or equal to 0, has to be 0 or a positive number, because any number squared has to be positive with the exception of 0, which is itself. So then we know if that's the case, then our answer would have to be x equals plus or minus whatever the square root of a is. And we know some numbers are perfect square numbers and some numbers are not so perfect. So if we bring out our two examples here, and we did x squared is equal 16, most people would say, okay, well that's not bad. We would take the square root of both sides as our step. And when we take the square root of both sides, we get x equals plus or minus square root of 16, which most of us know is 4. So we get nice two whole numbers. So what that really means is if you go back to the original equation, again, which was this, x squared equals 16, then your 4 and your negative 4 will make that statement true. Okay? Same thing here. If we did x squared equals 49, we're saying take the square root of both sides, nice perfect square numbers, t equals plus or minus 7. Now the question will come up, well, what if it's a not so nice number? If t squared equals 24 instead of 25. 24 is not a perfect square number. We still expect you to be able to take the square root of both sides, which you would do, and you'd get down to t equals plus or minus the square root of 24. But you've learned that the square root of 24 can be broken down, and if it contains a perfect square number, it must be broken down, simplified, so to speak. It's sort of like the reducing of fraction work. So in this case, you want to be thinking of that square root of 24 as probably the biggest perfect square, and it is 4 times 6. And 4 is the perfect square number, so it would come out, and we would have a final answer of plus or minus 2 root 6. We'd leave it just like that. We would not write the messy decimal form of that. This is the exact answer. 2 root 6 times 2 root 6. Think about it. Multiply it back out. 4 times 6. 4 times 6 is 24, which is exactly where we started. So it works nicely. You are going to have to handle your square roots, though. If they're not perfect square numbers, you will need to rewrite them and make them simplified. Now, properties of square roots that we've worked with, that we want to make sure we're okay with. The product rule. If you have two numbers that are perfect squares or non-perfect squares, so it's just any two numbers, as long as they are positive numbers or 0, then you could break it up. So that was the example that I just did on that last page. What if I don't get a perfect square root underneath here? What if I get, let's say, a 48? That's not a perfect square number. Then it's my job and your job to then break it down. And the best scenario is to use those perfect square numbers. So off on the side of your paper in your head, you need to have, well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared, 7 squared, etc. Right on up, because those are your perfect square numbers, and those are the numbers you're looking for. So in this scenario with the 48, The biggest perfect square number that goes into 48 from that list is our 16. We need to be thinking of it as 16 times 3. Yes, they're still both square roots because they're not perfect square numbers. And the square root of 16 times square root of 3 will get us back to the square root of 48. But from there we can break it down further because now we know square root of 16 is really 4 and 4 root 3 is our best choice. Now, when it's a problem like this and it's not x squared equals, then we're only going with square root of 48 is equal to 4 root 3. Because we don't have our variable, this is saying what is the positive square root of 48? So the positive square root of 48 is 4 root 3. So you don't put a plus and minus in this situation. Only on an equation where it's asking what are all possible solutions to this equation. Same thing happens when we have quotients. Again, we're talking about positive numbers underneath, and if you end up with, let's say, a fraction, and you don't like your fraction, and your fraction can't be reduced, but it's still square rooted, you must think of it first as separate numbers before you can break it down. If 4/9 doesn't break down, how about the square root of each? And in this case it does work. Square root of 4 is 2, square root of 9 is 3. We end up with the answer of 2/3. And again, it's just the positive square root. If they wanted more than that, maybe they would have put a plus minus out in front to begin with. Well, then you're going to have a plus minus in your answer. So it's just go with how the problem's written. Now, if I would have said x squared equals 49, 4/9, and we went through the process, this would be like we did on the last slide. We went through the process and took the square root of both sides. In this situation, x would be equal to plus or minus, and then doing your square root gave us the 2/3. That would be a true statement. But that's different than just saying, what is the square root of 49? Okay, when you're solving for a variable, that's a little different look, and that's what you're going to have to keep in your mind, even though it's just a slight change. So properties, products, and powers. So we could very simply ask you, in today's work, which we will, something like 4x squared plus 5 equals 20. So let's do that. Solve this quadratic. All right, so you look at it and say, well, wait, I don't have my squared by itself, so that's step 1, no big deal. And we get 4x squared equals 15. We would divide both sides by 4 to get the squared by itself. X squared equals, it is a fraction in lowest terms. We have not solved for x yet. That would be the next step. So we would take the square root of both sides. And when we take the square root of both sides on this one, x equals plus or minus, because I can get a positive times a positive and a negative times a negative to work in this. And then I have to look at both parts separately. Square root of 15 divided by the square root of 4. Now ask yourself, in the 15, are there any perfect square numbers that go into 15 that I could use to break down? And then in the 4, you should recognize that it is a perfect square by itself, so we are going to get that whole number of 2. What about that 15? Did you find anything? 1, 15, 3, and 5 are the only factors that go into it, so I believe that's a no. So we'll put our plus minus back out in front. Square root of 15 over 2 would be our final answer. You had a lot of work also in geometry with sides of a triangle, let's say in a right triangle, and if our sides, maybe they gave us a hypotenuse, maybe they gave us a edge, and let's make that an 8. It doesn't look like a 3. In order for this to work out, if we said find the missing piece, then you'd go through and use your Pythagorean theorem. Same thing, that's what we're asking for here. So if we did this one, we knew that the square of the legs of the triangle added together must equal the hypotenuse squared. So we would say a squared plus b squared equals c squared. We'd start working it out. This is where our perfect square is involved. We could do our 64. We could do our 196. We could subtract our 64 from both sides. Get x squared equals 132. We would have to take the square root of both sides, try to break down that square root of 132. No, we're going to get a plus or minus, but actually no, because it's a real life situation with the triangle. We know we won't get negatives, so we could go ahead and erase that, and all we'd have left to do is simplify what is the square root of 132. We're not looking for decimals. I don't think any of your, I shouldn't say that. Some of your answers today will say round or give answers to the nearest tenth. Then you will go to your calculator. So if this is one that said round to the nearest tenth, then we're going to take the square root of 132. You can do that with your calculator. The square root of 132, and I don't have a square root on this calculator, so you do the square root of 132 and round to the nearest tenth. So square root of 132 should equal to the nearest tenth 11.5-ish. And that would be our answer based on their rounding directions. So you're going to see typical problems like that in today's work, taking equations that don't set up to be x squared equals a number to where you have to get them to be x squared equals a number solved, and we'll either keep them in exact form, or if there's rounding directions, you will go for the rounding. So that's all there is, and happy quadraticing.